once again. So this will be the continuation of our discussion regarding with the electric charge and the electric force. So for today's agenda, so you must able to describe using a diagram charging by rubbing and charging by induction. Second is for you to explain the role of electron transfer in electrostatic charging by rubbing. And lastly, you must able to describe experiments to show electrostatic charging by induction. Now, without further ado, let's now proceed with our main discussion. Now, before, in the early observation of the electron, so basically, the term electron was being derived from the Greek word electron and from the Latin word electrum, which means that these electrons are discovered with the use of amber. So, how does this amber contribute in discovering the electron? So, because of the static electricity that they use or they have discovered as they rub the cloth on the amber, so the result of the static electricity, the following scientists before came up to an idea that electrons are there. Electrons are everywhere, and we can literally generate electricity without using, or let's say you can generate an electricity with a simple thing. Okay, now if you're going to search on the website, on the various books, if you are going to observe there or going to look for a little experiment for the electricity, there is so many experiments or activity that you can do it at home. Okay, now if there's something that it needs guidance with your parents or guardians, then you can ask for their help. Okay, now as this amber was being discovered to use this static electricity, and that's where they also discovered that with the use of silk cloth and a glass rod, you can also generate also a static electricity. And fun fact, don't you know that you yourself can also generate a static electricity? By what material? So you can grab any kind of a pen, and then you can get a little piece of paper. So as you rub the pen on your head and you try to put it on the little piece of paper, there will be a result of a electrostatic, or let's say a magnetism style, which is just the same with this silk cloth and the glass rod. So as you can see, as you rub this cloth, okay, to this rod, okay, always assume that the following materials has a composition of positive and negative charges. Okay, so as you rub the following materials or rub this cloth, eventually, as you can see, when rubbing the glass rod, the rod becomes positively charged. The question here, where does the negative charge go? So the negative charge goes to the cloth. Another question is, why does negative charge only, not the protons? Because if you're going to go back again in the history in some literature supporting studies, electrons are the ones who transfer. They have ability to flow, the flow of energy, so on and so forth. That is why, as you rub this, okay, if you rub this one, all the negatives will transfer, or negative charge will transfer to the cloth, and this will give a result that the glass rod will leave a positive charge. Now, once there's a tons of positive charge on a certain glass rod, and you try to magnetize, example, a can. Okay, if you have a can here, and therefore, again, assume that the can has a positive and negative charges. So, because the glass rod has a greater amount of positive charge, therefore, this can will now attract to what? To all negative charges. That is why you may able to push it with the use of glass rod without able to touch it, okay, and so on and so forth. Now, what will happen, sir? What will happen to the negative charge here on the cloth? And eventually, just simply released in the atmosphere or in the environment, okay? So it says here that the C-cloth, when placed on a contact with the rod, will attract the negative charge more strongly. So, but then again, it will released in the environment or the atmosphere. Why? Because aside from this, the electric charge or the electron has a possibility to transfer their charges between objects, they are also following the law of conservation, that in every object that we have or that we're able to touch or any non-living matter, they're always in a state of conservation, which means that they are what? Always in positive or negative or neutral state, rather. Neutral. That's why if you're going to move the can, okay, move the can without touching it with the use of glass rod that was being rubbed to a cloth, so eventually this will not last long. Okay, this and this will not last long because after a short period of time of attraction, right after that, it will now go back to its neutral state. Okay, and take note that overall charge of the system is zero before charging. They're always zero. It means, again, they are neutral. Okay, now, to support this discussion, here are some following questions that we may answer so that we can practice and go further to our understandings. Now, example. So, complete the following statement. Now, when a glass rod is rubbed with C-cloth, the rod becomes positively charged as what? Is it A, negative charges are transferred from the rod to the silk? B, negative charges are transferred from the silk to the rod. C, positive charges are created on the surface of the rod. D, positive charges are transferred from the silk to the rod. Or E, positive charges are transferred from the rod to the silk. So eventually, you will answer various letters to that. You always have a hunch. But if you're going to analyze, so it's a matter of negative. Okay, again, our notes that, or our keynotes is that always the negative who transferred. So our answer will be negative charges are transferred from the rod to the silk. Okay, always the electrons. Electrons are the ones who are spinning around the orbit of a certain atom, which the proton always attached to neutron, right? So eventually, if you have here, if we're going to illustrate the atom, here's the atom, right? We have the neutron, the proton, okay? And then the orbiting, here are the electrons who orbit. So if you have two protons inside the atom, therefore you have two electrons also. They are equal because the attraction is 1:1. Okay? Next, glass is a very good electrical insulator. How is then possible that a glass rod can be charged by rubbing it with cloth? So again, A, when the rod is rubbed, it becomes an electric conductor. B, although the rod is an insulator, any excess charge will slowly be conducted away. C, when the rod is rubbed, the part of the rod that is in contact with the cloth becomes electrically conductive. D, electrons are stripped away from the atoms in the glass and transferred from the C-cloth. This leaves the glass rod with more positive and negative charge, so you get a net positive charge. And E, none of the above answers are correct. So upon learning the definitions in the previous slides and supporting discussions, okay, what do you think will be the best answer? Okay, so the answer is D. Again, electrons are stripped away from the atoms in the glass. So again, as you use these following materials and rub it, So you rub it down, all the negative will be transferred here on the cloth. Okay? And this will leave a positive charge. And then that's why you can use to attract other objects who are in neutral state. Okay? In neutral state. So again, attraction. So if you have a greater amount of positive charge, it can attract all the negative charges here. Next. Now, by charging by contact and by induction, so there's a big difference between that. So allow me to discuss with you the charging by contact. So the principles of this one is when charged object contacts a neutral object, they both acquire the same charge. Okay? So just simply that the total charge of the system is preserved and they distribute the total charge according to their capacities. So if we have here the metal sphere, okay, if we have here a metal sphere with a minimal, or not, let's say minimal, it is in a neutral state. That's a positive, negative, positive, okay. Now, you try to charge it, then therefore, it will now acquire the same energy or it will increase its negative charge. So that's charging through contact when it needs to be touched. Okay? It needs to be touched. Now, it may depends, it may varies its sizes because the distribution is always total charge according to their capacities. So if you have a small object, then therefore just simply occupy a minimal charge. If you have a large object, then therefore it requires a greater amount of charge. Okay? So if you're trying to put a greater amount of charge here in the small object, okay, then it will be overcharged. If you're going to charge this big object with a minimal charge, then therefore it will not compensate, or it will not be enough for an object to proceed whatever it is function. Okay. Now, again, this is the charging a neutral object by conduction. Okay, so in the diagram 1, as you can see, a neutral metal spheres rest upon an insulating platform. It means that this is still in a neutral. Now, when the positive aluminum plate is touched to the metal spheres, electrons are drawn from the sphere and onto the aluminum plate. So therefore, as you observe this one, the charge of this aluminum plate transferred here in this our neutral object. And therefore, if you're going to proceed to diagram 3, the charge of this object is just also the same to our resting object. And now, we can now consider that this object is now charged. Okay? Next, charging by contact and by induction. We're done with the contact and we're now proceeding to induction. So at this point, it is a charges on an object without direct contact with another charged object. Okay, now this charged particles is held near an uncharged conductive material, and this uncharged conductive material is grounded on a neutrally charged material. So if you're going to observe, we have three samples. Okay, or let's say these three neutral object. Now, if going to observe this diagram A, if you will see that it is still in a neutral, they are uncharged. Okay, so the charges are balanced, the protons and the electrons. Now, if we're going to charge that, it's just simply stripping away all the identical charges. So, what do you mean by stripping away? So, if you have a positive and negative, this will result in attraction. If you have a negative, negative, or positive on positive, that will be repel. And as you put this rod or the ebonite rod on this one, all the negative charges will be stripped away through in a process of grounding, which go to connection to the ground or going back to the earth surface. Okay, and this will leave a certain object to be neutral. Okay, or let's say be charged. So again for the conduction, it's a matter of charging with direct contact. It needs to be touched. Now, if you want to charge a certain an object without touching it, then you will be using the induction process where you will be grounding it. Okay? So here's the example for that to support for this definition and further understanding of induction. So again, in a diagram A, we have here the two metal spheres mounted in insulating stands, and then this represents a charge induced to remove sphere A to B. So it means you're going to transfer its charges to B, the sphere B, or the grounding. That's what I'm trying to say, or providing the examples a while ago. Again, this one is in a neutral state, and which has a positive and negative charge, and this one has a no charge at all. So if you're going to charge this B without direct touching it, okay, with the use of this maybe this is a balloon, then therefore you just simply charge the A, and all the excess charge of oil can ground this sample B. And with that, again, if you're going to proceed to diagram 4, the excess charge distributes itself uniformly over the surface of the spheres. It means you have successfully charged the other object. Okay, it's like a relay of energy. Okay, if you cannot reach the certain object to charge it, then you can charge first object and transfer it to the other one. So it's a matter of relay. Okay, and please take note that the negative charge rod induces a slight positive surface charge on the plastic. Okay, now for the further questions, allow me to go further within it. Now, an initially electrically neutral conducting sphere is placed on an insulating stand. A negatively charged glass rod is brought near but does not touch the sphere. Without moving the rod, a wire is then attached to the sphere that connects to earth ground. Now, the rod and wire are then removed simultaneously. What is the final charge on the sphere? So, please take note that we have a negative charged glass rod but does not touch the sphere, and without moving the rod, a wire is there attached to the sphere. So again, if you have a negative charge and if the object has a positive and negative, again, this is the rod has a negative charge, and you're going to charge this object, okay? So all the negative charge will be stripped down, and therefore this will leave as a charge of positive. Okay, next, an initially electrically neutral conducting sphere is placed on insulating stand. So it's just the same with the first question, but this time the rod and wire are then removed simultaneously. So subsequently found that to have a negative charge. It means that it doesn't touch, right? It doesn't touch, okay? does not touch the sphere, but then it gives the certain object with a negative charge. What do you think will be the best answer for this one? So, if a certain object still leaves a negative charge instead of a positive charge, and therefore, there is another experimentation was being conducted to that. So, we could not, we can conclude right away, but we can look for some other possibilities or some factors what happened to that. It's a matter of observation. Okay? Next. Now, three identical conducting spheres are on individual insulating stands are initially electrically neutral. Now, the three spheres are arranged so that they're in a line and touching as shown. A negatively charged conducting rod is brought into contact with sphere A, and subsequently, someone takes sphere C away. Then someone takes sphere B away, and finally, the rod is taken away. What is the sign of the final charge if any of the three spheres? Okay? So again, this A, B, and C are in a positive and negative. It means that they are in a neutral state. So if they are, okay, they are conducted, the distribution of this charges, and suddenly it was being removed. Okay? So the answer will be here is letter E. The letter E. Negative, negative, and negative. Okay? Because, again, the process here is contact and induction. Why? The contact here is from the A, and then the induction here where the charges transferred from B and C. Okay? And lastly, three insulating balls are hung from the wooden rod using thread. The three balls are then individually charged via induction. So subsequently, balls A and B are observed to attract each other, while ball C is repelled by ball B. Which one of the following statements concerning this situation is correct? So is it A? A and B are charged with charges of opposite signs, and C is charged with charge that has the same sign as B. Or B, A and B are charged with charge of the sign, and C is electrically neutral. C, A is electrically neutral, and C is charged with charge that has the same sign as B. Or D, B is electrically neutral, and C is charged with that has the same sign as A. Or E, choices A and C are both possible configuration. Then again, it's a matter of observation, and this kind of problem, this make us have a result of letter E. It should not be E. It should not be D. It should be E. Okay, it should be E. Where the A and B are charged with the charges of opposite sign, and C is charged with a charge that has the same sign as B, and A is electrically neutral, and C is charged with charge has the same sign as B. Okay? Because, again, A and B are observed to attract each other, but ball C is repelled by ball B. Okay? So that is how we going to observe and answer the following certain problem. Now, in application for that in real life situation, again, you need testers, or if other than that, if you don't have testers, at least you have observation. Okay, you take note of the following and then what you observe, and try to search for the supporting studies that why does this a certain behavior occurred. Okay? And that will be the end of this discussion. For the next video, I'll be discussing about the predicting the charge distribution, and also I'll be also discussing the Coulomb's law. Okay, and with that, thank you and see you on the next video.